Hey math kids, we're going to continue talking about differentiation and integration of Maclaurin series, and this time we're given cosine just like the last video, but we want to find cosine of x squared, and then we want to estimate that integral that's written on the screen. Okay, so the first thing is cosine of x squared. We're just going to use this but plug in an x squared for the x. And when we simplify that, we end up with that. So part A, that's the answer. Now part B, so this was A, this is B. Part B, we need to estimate this out to 4 decimal places. And so we're just going to put in integral from 0 to 1 and put a dx right there. Okay, and when we do that, all of this is just a constant, so it can come out front, and so we're going to rewrite that. And then think of our integral like that. Okay, we can just rewrite this. Now remember, we raise this by 1, divide by the new one, and evaluate that from 0 to 1. Don't forget about this constant out in front, but I'm going to just focus on this and then put that constant back when it's convenient. Okay, so if I plug in a 1 to this, I'm going to get 1 to the 4k plus 1 over 4k plus 1 plus 0 to the 4k plus 1 over 4k plus 1. This should be minus, actually. I don't know why I did plus. Okay, subtraction. 1 to anything is going to give us 1, and so that's just going to give us 1 over 4k plus 1. 0 to anything is 0. 0 divided by anything is 0, and so we just end up with this, and then we just need to tack this on as well. So then we get negative 1 to the k, 2k that, and then we get 4k plus 1. Okay. Now I need a little bit more room, so I'm just going to get rid of this stuff. Now we're trying to estimate the value. So, and we want to do it out to 4 decimal places, I think. Let's see. Yeah. So, when we're doing this, we just plug in a 0 and see what happens. So if we plug in a 0 here, we get 1. If we plug in a 0 here, we get a 1. Plug in a 0 here, 1. 1 times 1 is 1. So that first term is just going to be 1. Now the next term, plug in a 1, we get a negative. Plug in a 1, that's 2 factorial, which is 2. And plug in a 1 here, that's 4 plus 1, so we get 5. So that's going to be 1 over 10. If we plug in a 2, that's a positive. If we plug in a 2 here, we get 4 factorial. And plug in a 4 here, we get 16, 17. Oh, wait, sorry. 0, 1, 2. We were plugging in a 2. So 8, 9. Okay, next one, if I plug in a 3, okay, 0, 1, 2, 3. Help me keep those straight. If we plug in a 3, we're going to get a negative 1. If we plug in a 3 here, we're going to get 6 factorial. If we plug in a 3 here, we're going to get 12 plus 1, which is 13. And just for good measure, let's plug in 4. So if we plug in a 4, we get a positive 1. If we plug in a 4, we get 8 factorial. If we plug in a 4, we get 16, and then 17. Okay. I'm going to go to my calculator to help me with some of this, just to simplify it. Okay. So 1 over 1 is 1, minus 1/10. 4 factorial, 4 times 3 times 2 times 9. That's 216. Okay, now we do 6, 5, 4, 3, 2 times 13. 60. And then 8 factorial, 8, 7, 6, 5, 4, 3, 2, 1, and then 17. Okay. 6, 8, 5, 4, 4, 0. Now with the patterns, that would be subtraction, and we would keep going. Now, if we just plug this into a calculator, so 1 divided by our answer, we're going to see that this is like really far out there. So like just this part is 0.000000146. And so that should take us out to the 4 decimal places that we require. And so we're going to do 1 minus 1/10 plus 1 over 216 minus 1 divided by 9360 plus 1 divided by 685440, and we get 0.9045. So this thing is approximated at that if we round it to 4 decimal places.